Throughout the entire universe, normal matter, such as the stuff that makes up us, the planets, stars, etc., only makes up an estimated 5% of the total mass of the cosmos. The question then is, well, if the universe is 95% non-ordinary matter, then what exactly is that 95%? Current research suggests that the vast majority of the universe is made up of dark energy and dark matter. The term dark could be replaced with the term mystery, because we don't know the exact nature of either dark matter or dark energy. In fact, we aren't even totally sure that dark matter and dark energy even exist. Dark energy actually has a really long history, going all the way back to Einstein's general theory of relativity. When Einstein was creating the general theory of relativity, he was coming across a really strange problem. Basically, Einstein's general theory of relativity was suggesting that the universe was expanding. Now, to him, this didn't make sense because he, just like many other people at the time, believed that the universe was static. So, to correct this, Einstein placed into the mathematics a constant, which is now referred to as Einstein's cosmological constant. I know, very, very creative name. Later, Edwin Hubble discovered that the universe actually was expanding, and so Einstein removed his cosmological constant from his mathematics, and he was even ashamed by his cosmological constant. But this was not the end of Einstein's cosmological constant. Fast forward to the 1990s, and astronomers discovered that not only is the universe expanding, but its expansion is accelerating. This was puzzling to astronomers and astrophysicists everywhere because it seemed impossible to explain. This was where Einstein's cosmological constant came back into play. Quantum physicists began researching into the possibility that Einstein's cosmological constant might have something to do with this acceleration. These quantum physicists associated it with, and I quote NASA here, the energy of a vacuum. There has been a lot of evidence supporting the idea that dark energy does exist and dark energy is responsible for the acceleration of the universe. But there's no real explanation as to what dark energy really is. And just because there's evidence that supports the idea that dark energy exists, that doesn't prove that dark energy really exists. There is a chance that dark energy might not exist at all. The idea of dark matter was first proposed by Fritz Zwicky from Caltech in the year 1933. At this time, there was a huge problem in astrophysics. Basically, research was suggesting that there wasn't enough matter in the universe for galaxies to stay together, especially fast-moving galaxies. In other words, if you kind of view astrophysics and astronomy, and basically any science, as a puzzle, there was a gigantic chunk of this puzzle missing. Zwicky proposed the idea that there could be invisible matter, making up a large portion of the universe to explain how galaxies are able to stay together. For many years, there was no real way to test this idea. That is, until the 1970s, when Vera Rubin and Kent Ford discovered the earliest evidence of dark matter. To quote the US National Science Foundation, Rubin and Ford discovered that the outer stars in a spiral galaxy rotate as quickly as those at the center, which suggested that there had to be something else in the galaxy providing extra gravity. This was a massive breakthrough discovery, and it was so significant that even to this day, dark matter is a huge talking point for physicists, quantum physicists, astronomers, and astrophysicists everywhere, and for scientists all over the place outside of these science fields. Dark matter is such a fascinating topic that it captures basically everyone's interest. Today, there is a lot more evidence that dark matter exists. But, just like dark energy, there is still no explanation of its real nature. Nobody knows what it really is. And there is a chance that dark matter might not exist. Dark matter and dark energy are very, very complex topics with tons of research, papers, and decades, literally decades of work. So do some research on dark matter and dark energy, and let me know what you think about this video and what you think about dark matter and dark energy in the comments. And as always, never be afraid to ask questions.